Why does profit usually increase when capital increase? Why does savings generally increase when expenditures decrease? Why does blood pressure increase when one gets older? These are some questions that are asked concerning relationship between two variables or quantities. Data that involve two variables are called bivariate data. In bivariate data, the purpose of the analysis is to describe the relationship between two variables. The statistical procedures that is used to determine and describe the relationship between two variables is called correlational analysis. Correlation means association. More precisely, it is a measure of the extent to which two variables are related. There are three possible results of a correlational study: a positive correlation, a negative correlation, and no correlation. In a positive correlation, as one variable increases, the other variable also increases. An example of positive correlation would be height and weight. Taller people tend to be higher. So, ibig sabihin, the correlation is direct. A negative correlation is a relationship between two variables in which an increase in one variable is associated with a decrease in the other. An example of negative correlation would be height above sea level and temperature. As you climb the mountain, mag-i-increase ang height and it gets colder and magdi-decrease naman ang temperature. So the correlation is inverse. A zero correlation exists when there is no relationship between two variables. Halimbawa, there is no relationship between the amount of tea drunk and level of intelligence. Take note that correlation does not imply causation. Even if there is a correlation between two variables, hindi natin pwedeng i-conclude that one variable causes a change in the other. This relationship could be coincidental or a third factor may be causing both variables to change. Many researchers find difficulty to the appropriate statistical tools in processing data. It is a must that researchers diagnose the problem by using the appropriate statistical tool to arrive at accurate and definite interpretation of results. Sabi nga po, ang researcher daw ay similar with a physician. So, ang physician ay nagda-diagnose ng ailment at nagpe-prescribe ng appropriate medicine to cure the ailment. An ailment cannot be cured if the physician prescribes inappropriate medicine. Ganon din po sa research, kapag mali yung ating statistical tool na ginamit, possible na mali yung ating result. The statistical portion is a vital component of any research study. Using statistics correctly is very important para ma-maintain ang integrity of data. If the given variables are like this, the independent variables are the profile of the students in terms of age and sex and the attitude towards math. The dependent variable is the level of mathematics achievement of the students. If we correlate the age and level of mathematics achievement, ano ang appropriate statistical tool na pwede natin gamitin? The independent variable is the age and the dependent variable, the level of mathematics achievement. Ang age natin ay ratio, level of mathematics achievement ay also ratio. We can utilize Pearson product moment correlation or Pearson's R, provided that the assumptions about parametric assumptions are satisfied by our data. The Pearson product moment correlation coefficient or Pearson's R is a measure of the strength of a linear association between two variables and it's denoted by R. What are the assumptions? 1. Your two variables should be measured at the interval or ratio level. Our example or our variables are age and level of mathematics achievement, so they are continuous. 2. There is a linear relationship between your two variables. If you draw a scatter plot and you put variable 1 in the x-axis and variable 2 in the y-axis, if the pattern is a straight line, there is a linear relationship between two variables. Third assumption, there should be no significant outliers. Outliers are simply single data points within your data that do not follow the usual pattern. For example, ang mathematical achievement po natin, ang data ay line lahat ng 7 or line ng 8. For example, 78, 79, 85, or 84. Merong isang 95. So, yung 95 na yon, siya yung outlier. Pearson's correlation coefficient or R is sensitive to outliers, which can have a very large effect on the line of best fit and the Pearson correlation coefficient. Therefore, in some cases, including outliers in your analysis can lead to misleading results. Fourth assumption, your variable should be approximately normally distributed o yung tinatawag nating bell shape. We can check assumptions number 2, number 3, and number 4 using SPSS statistics or any software like JAS. Remember that if you do not test these assumptions correctly, the results you get when running a Pearson's correlation may not be valid. If we correlate sex and level of mathematics achievement, the independent variable is sex, male and female, and the dependent variable, level of mathematics achievement. Sex is nominal. Level of achievement, again, ratio. We can use point-biserial correlation. A point-biserial correlation, it is a special case of the Pearson's product moment correlation, which is applied when you have two continuous variables. What are the assumptions of point-biserial correlation? First, one of your two variables should be measured on a continuous scale. Second, your other variable should be dichotomous. Third, there should be no outliers for the continuous variable for each category of the dichotomous variable. Fourth, your continuous variable should be approximately normally distributed for each category of the dichotomous variable. And last, your continuous variable should have equal variances for each category of the dichotomous variable. We correlate attitude towards math and the level of mathematics achievement. What is the appropriate statistical tool? The independent variable, the attitude towards math, and the dependent variable, level of mathematics achievement. Attitude towards math ay ordinal. Bakit siya ordinal? Kasi gumamit tayo ng scale. We can use a Spearman rank correlation provided that the assumptions about non-parametric assumptions are satisfied by our data. Spearman rank correlation is a non-parametric version of the Pearson product moment correlation. The test is used for either ordinal variables or for continuous data that has failed the assumptions necessary for conducting the Pearson's product moment correlation. What are the assumptions of Spearman rank correlation? Your two variables should be measured on an ordinal or continuous scale, and there is no monotonic relationship between the two variables. A monotonic relationship is a relationship that does one of the following. As the value of one variable increases, so does the value of the other variable, or as the value of one variable increases, the other variable value decreases. For example naman po, ang variable 1 natin ay life satisfaction, satisfied and unsatisfied, and ang variable 2 ay happiness in life, happy and unhappy. Variable 1 is a nominal, variable 2 also a nominal, and we can use chi-square or phi coefficient. The chi-square test of independence determines whether there is an association between categorical variables. It is a non-parametric test, and the frequency of each category for one nominal variable is compared across the categories of the second nominal variable. The data can be displayed in a contingency table where each row represents a category for one variable and each column represents a category for the other variable. The word contingency refers to dependence, but this is only a statistical dependence and cannot be used to establish a direct cause and effect link between the two variables. We have phi coefficient and Kramer's V. These two tests are chi-squared based measure of association. A phi coefficient is a non-parametric test of relationships that operates on two dichotomous variables. Dichotomous means that the data can take on only two variables, like male, female, yes, no, opinion or fact, and control or treatment. It intersects variables across a 2x2 matrix to estimate whether there is a non-random pattern across the four cells in the 2x2 matrix. What does this mean? Here is an example of dataset. Variable 1, life satisfaction, and variable 2, happiness in life. In life satisfaction, nag-code tayo ng 1, satisfied, 2, unsatisfied. Happiness in life, 1 ang happy, 2 unhappy. From the data, 3 ang satisfied and happy, 1 ang satisfied but unhappy, 1 unsatisfied and happy, and 2 unsatisfied and unhappy. The data in the cell should be frequencies or counts of cases rather than percentages. Similar to a parametric correlation coefficient, the possible values of a phi coefficient range from -1 to 0 to +1. And we have Kramer's V. Kramer's V is the most popular of the chi-square based measure of nominal association because it gives good norming from 0 to 1 regardless of table size when row marginals equal column marginals. Variable 1, religion, ABC, and variable 2, opinion about divorce, favor, against, and neutral. First variable, nominal, and the second variable also nominal. For a 2x2 contingency table, Kramer's V and phi coefficient are equal. Kramer's V gives exactly the same value as the phi coefficient. Phi coefficient and Kramer's V are chi-squared based measure of association. We can use Pearson's R if one variable is continuous and the other variable is also continuous. We can use Spearman's rule if one variable is ordinal and the other variable is continuous. If both ordinal, we can use Spearman's rule or chi-square. If one variable is nominal and the other variable is continuous, we can use point-biserial correlation. If one variable is ordinal and the other variable is nominal, we can use chi-square. And if both variables are nominal, we can use chi-square.